Hello, this is Jennifer Martinez. In this video we're going to solve a trig equation using the quadratic formula. So we're going to solve the equation for the solutions over the interval 0 to 360 degrees, this homework problem, which is cotangent of theta plus 2 cosecant of theta equals 8. So for step 1, I'm going to change all the trig functions to sine and cosine. To do that, I'm going to see cotangent. We know cotangent is cosine of theta over sine of theta. So then we have cotangent of theta plus 2. Cosecant we know is 1 over sine of theta. And then we still have the equals 8. So now I'm going to get a common denominator, and what I would have there is cosine of theta plus 2 over sine of theta equals 8. And I'm going to simplify by getting that common denominator, and I don't like fractions, so I'm going to go ahead and multiply both sides by sine of theta to get, on the left side, cosine of theta plus 2, because the sine of theta is cancel, and the right side, 8 sine of theta. Okay, so now, let's put the step 1 there. Step 2, we're going to square both sides to use sine squared plus cosine squared is 1. So I would like to square both sides right here. And let me scroll down a little bit, and that would give me cosine squared plus, you have to use FOIL. So that would be cosine squared plus 4 cosine of theta plus 4. The right side would just be 64 sine squared of theta. So now I can use change all to cosine. I'm going to change all to cosine because I have a cosine theta here, and changing sine squared to 1 minus cosine squared would be easier than the other way around. Doing that, the left side would be the same. The right side would be 64. Instead of a sine squared, we're going to write 1 minus cosine squared theta. Okay, so that would be what we did there. Let's multiply that out. And you would use the Schroeder property. Okay, so we're on step 4. What is step 4? Step 4, right? Are we on step 4? Yep. Okay, so what we're going to do next is we're going to set one side equal to 0. So we can solve using the quadratic formula. So I'm going to do that by adding 64 cosine squared to both sides, and also subtracting 64 from both sides to get 65 cosine squared plus 4 cosine theta minus 60 equals 0. So that's allowing me to use the quadratic formula. What is the quadratic formula? If you remember from your algebra days, it's negative b plus or minus the square root of b squared minus 4ac all over 2a, where the a is the coefficient in front of the x squared, the b is the coefficient in front of the x, and c is the constant. So instead of x, our x is cosine of theta. So we're going to have cosine of theta is equal to negative b, so negative 4, plus or minus the square root of b squared minus 4. A, which is 65, and c, which is negative 60, all over 2 times a, which again is 65. Using your calculator to figure the inside of the radical, you would get square root of 15616 over 2 times 65, which is 130. Figuring that out on your calculator, you're going to get 2 answers. The cosine of theta is equal to negative 4 plus the square root 15616 over 130, which is approximately 0.9305, or you're going to get that the cosine of theta is equal to the -4 minus square root of 15616 over 130, which is approximately equal to -0.9920. If you figure that out on your calculator. Let's put the O over here, because this equation, if you figure the inverse, cosine inverse of 0.9305, that would give you, so that would equal to theta, so theta would approximately equal to 21.5 degrees. And this one, let's put the theta first this time, cosine inverse of a -0.9920, so this one, theta would approximately give you 172.7 degrees. And those are the two answers. If you scroll up to the beginning, you can see, oh, I got 71.8. So I probably didn't go far enough. So let me go ahead and change that. Probably need to go farther here. So for instance, if we did the next digit, which is a 3, let's see if that would give it to us. It sure would, because this would be a 6. So they wanted it in 1 decimal place over the nearest tenth. Let's check that out. Yep. Right, type your answers in degrees. Do include the degree in your, do not include the degree in your answer. Round to 1 decimal place. And use a comma when needed. So now I did that correctly. It's actually a good idea to go much farther than I did to get accuracy. Don't round until the end. I do realize that cosine of something positive is also in the 4th quadrant, but I actually went and tried that one. I was wondering why there was not 4 solutions and just 2. And when you square by sides, if you remember from your algebra days, there are extra solutions. So when you square both sides right here and you try that -1 in the 4th quadrant, you're going to see it's not going to work. You can try it in your original. Right, so you can try 21 degrees, 21.5, because whenever you square both sides, you do have to worry about extra solutions, and you'll see it does work. And then if you tried 360 minus 21.5, which is where cosine is also positive, it doesn't work. And then here, the same thing. Cosine is negative in 2nd and 3rd, and this happens to be in the 2nd quadrant. If you try the 3rd quadrant, it's not going to work either when you plug it into the original. So that's because when you square by sides, you might end up with extra solutions. So it turns out that these are the only 2 solutions. You won't be tested on extra solutions, but just in case you wondered. Hope that helps.